The Alabama team is posing for a photo. They're ready to go. Has also left the bin, and so they're probably ready too. They're just communicating with their teammates in the control center to make sure that everything is working before they exit the arena. Any results that you see posted on the screen are unofficial results. Not only that, they don't take into account all the things that the official judges take into account, like how much the robot weighs and how much communication bandwidth the robot uses and whether or not the team was fully autonomous. Only the judges have visibility into that detailed information, so we cannot show you those sorts of detailed results until the judges go over all their paperwork that they've been keeping track of this week and post official results at the end of the day tomorrow. Again, the two teams that are getting ready to run. On the left, University of Alabama. On the right, the University of Illinois, Urbana-Champaign. Okay, both teams are exiting the arena. As soon as the judges put some final touches on the arena, they will give the thumbs up to the timing judge. You'll notice sometimes teams attach things to the lander being the side of the arena that the robots are sitting on. On the U of I side, you can see a checkerboard pattern. That's usually used by a robotic vision system. It could be used by an automated system, or it could be used by a manual driver to give them feedback about how close they are to the hopper, or whether they're lined up or whether they're crooked. I see motion. We have started. This is the second official competition run for both of these teams. Alabama's robot looking back and forth, trying to figure out where it is, mapping the field. This is fully autonomous. Alabama's robot is crossing the obstacle field, not having any trouble crossing that field. Once it gets to the digging area, it's going to lower its bucket ladder digging system. Again, Alabama on the left. You can see some dust flying. They're definitely digging. Is the robot smart enough to know just what angle to put that digging implement in order to maximize its yield? You can see it keeps lifting it up. It's moving forward while it digs. There, it's moving forward. Lifting up. Oh, yeah. Yeah, it's getting some good regolith there. You can see it slow down a little bit when it starts to dig in. The spinning will slow down. Okay, it's done. It's decided it's going to go dump. Let's see how much Alabama has on board the robot right now. The robot has to align itself with the hopper and then turn on the conveyor. Oh, look at that coming out. That's a lot of regolith right there. University of Alabama. Heading back for another run. 2.5 minutes in. All right, on U of I side, we finally see some movement from this robot. Meanwhile, Alabama's back in the digging area for their second drive. Alabama has about 12 kilograms in the hopper from that first run. This Alabama robot performing better today than it did yesterday. You can see this cycle that it does. It puts the digger down, it drives forward, and then it backs off, and the digger goes up, and then it does it again. Three and a half minutes in, Alabama's going back to dump. Back to the lander. Meanwhile, the U of I robot, it got out of the starting gate, got halfway through the obstacle area, and stopped moving. Okay. I just saw U of I's digging system move just a twitch. So obviously the U of I students in the control room are trying to control that robot. Alabama robot got a little lost there. He's looking around. Is it a he or a she? He. Okay. Now the team is watching. The Alabama team is watching. Is it worth the pain to watch this robot go back and forth and back and forth? How long do they give it before they take over manual control? The robot appears to be nodding back and forth, looking for its location in the arena. Where is that hopper that I'm supposed to drive to? At some point, the students are going to give up. If this continues, they'll give up on the autonomy points. Right now, the students know that the scale is holding 12 kilograms on the Alabama side. Honestly, if this continues, this robot may end up digging itself down into a hole.
Call it. Call it.
4.5 minutes remain. All right, something's happening on the Alabama side. Something may be rebooting, not sure. Are they going to let it go and get the fully autonomy points? They do have 12 kilograms, which qualifies them. Alabama students on the left, 12 kilograms in the hopper, and a robot that is not there. There it's moving again. Kind of looks like we have hands on a keyboard, maybe. Hard to tell from the video feed. Only the judges know for sure whether the students are controlling this robot or letting autonomy continue to work. Okay, Alabama's unloading their second load. 3 minutes remaining. U of I have not seen their robot move in quite some time. U of I was able to turn their robot and get halfway across the obstacle area.
Watching Alabama do their final run of the competition.
Which is a feat in itself.
The robotic mining competition.
Driving a robot on top of
the
this
stream.
regular simulate is not always easy.
Win. Okay.
All right, Alabama's going to take another try. Digging in. They're hitting it pretty hard there. But every time they do that, they're getting some... There they go. There they go. They found a happy medium there. They found a digging height. And they're going for it right there. The wheels are moving forward. They're digging as they move forward. And they're resetting. Right now, we are under 2 minutes remaining. This robot on the Alabama side is pretty quick. It'll get back to the other side pretty quickly. The students are watching the clock. 1:35 left. They decided that's enough. We need to make sure we have enough time to get back to the lander and dump this load onto the lander. 1:20 left. Alabama dumping quite a bit of regolith there. With 1 minute left, what are they going to do? Are they going to try and dig some more?
Run. Just get manual.
Why wouldn't you? 1 minute left, 55 seconds.
Manual.
On the scale, Alabama has more than 40 kilograms. More than 40. All right, we have 40 seconds left. How much time do they need to head back to the lander and dump? "25 seconds. 20 seconds. And they're heading back. Only 10 seconds left. 9, 8, 7, 6, 5, 4, 3, 2. They were able to actually dump some. Hands off the controls. All right. So, after University of Alabama's second official competition run, they have 42 kilograms in the hopper. Congratulations, University of Alabama. Sadly, University of Illinois, Urbana-Champaign was unable to get